Morning, guys. Now, I'd like us to do um, exercise 2 on page 51. Uh, so this I can call video 1 or exercise 2 on page 51. Okay, guys, as I have tried to maybe impress on your mind that when you get a sum, a worded sum, or a worded problem, please try and visualize what it is that they're trying to ask you to calculate. Okay, so over here they say it's a circular column, has a head in the shape of an upside down frustum of a conical pyramid and must be cast in concrete. Okay, guys, first of all, once they say circular, you already know the formulas you need to know and apply are circular based types of formulas. Okay, so basically you need to know how to calculate the area of a circle, and you need to be able to calculate cylinders and conical shape frustum pyramid. Okay, I'm just gonna take and give you an example of how it might look just from normal day-to-day things. This is a yogurt container. This, when you put it like this, it's more like a pyramid, a frustum pyramid. But I'll take a picture and show it to you on the on the on the WhatsApp group. Okay, right. And then you've got like a cylinder, which is all the diameters are the same. So this toilet paper roll, this the diameter here on top, and then the bottom is the same. Unlike something like a frustum, because this the diameter of this lid of the yogurt container is much bigger at the top than at the bottom. Okay, so essentially the bottom part is the same diameter as the toilet paper roll. So I'll show you when they place together to form some sort of column with the head. Okay, that's fine. So when you visualize the stuff, mine is this. Before you do any calculations, draw what they're telling you so that you've got an image. So I can show you I've drawn what I believe that this is what they are alluding to. So here's the frustum, the upside down pyramid. So a pyramid in actual sense is like this. So they're saying to flip it, make it upside down. So it's like this, right, guys? That's just explaining the upside down part. Okay, that's a note. Upside down, right? Pyramid. Now, guys, they tell us that the diameter of the cylinder is 300 millimeters. So there I've put it in the drawing, 300 millimeters, and they tell us that it's got a height or a length that is 3000 millimeters. So that's 3 meters in when you're using a unit of meters. Okay, and then they say the frustum at the head is 1000 millimeters, which is also equate to 1 meter. So since we know that this structure is the whole structure, this is how the total structure should look. So we know over here the frustum will have a diameter at the bottom of the same size as the column. Okay, guys, so now what we need to do is to annotate on our drawing to show the sizes that are given in our detailed instruction. Okay, so now let's go to formulas that you need to know. The first formula you need to know is for the cylinder. The volume is equal to pi r squared times length. So basically you need to be able to give us a radius. So 300 millimeters by half, because diameter is 2 times the radius, give us 150 millimeters. Okay, and then we know that 3 meters and 3000 millimeters is the same. So when we substitute into the equation here, when we do the calculation, it's just volume is equal to pi times 0.5 squared times 3 meters. And that gives you 0.21 cubes concrete. That applies to the cylinder, guys. Okay. And then let's go further to the frustum, which is the upside down conical pyramid shape. Now, as per the department built environment and building, I am told that let us not utilize, there's a formula in the workbook here. They say don't utilize that one. They say utilize this one that says volume is equal to length over 6 times big area plus small area plus 4 times middle area. Okay, let me show you here in your module where that is. So they say use this one, the prismoidal formula, because in the prismoidal formula, just like in our frustum, we've got a big area and then we've got a small area, and we can determine the middle area. So how to determine the middle area? We need to take the bigger diameter and the smaller diameter, add them together, and then divide it by 2 to get the center diameter there. Okay, that will give you also a center radius that you can use in calculating the area of the center part. Okay, this is a quite simple formula once you get a grip of how it's used. One key note I need to tell you guys is that this L over length, the length is this one, is this 350 over here. You need to multiply it, you need to separate the entities it multiplies, because this L over 6 is multiplied throughout the equation. Okay, so you need to separate L over 6 times big area, L over 6 times small area, L over 6 times 4 times middle area. So that, because what's going to happen in your calculation, in your calculator, you're going to have an error if you put it all in as you look at it now. You might get an error in your answer. Okay, so this is how we substitute for it. We know it's 350, that is our length, so it's going to be 0.5 divided by 6 times big area. Big area is pi r times 0.5 squared. Remember, big A is the big diameter part, the orange part here that I've annotated. Okay, I might just make maybe a mark with this highlighter to show that that's where this one applies. And then you've got the small area. There it is. I've highlighted that one also. So that one is 0.5 divided by 6 times pi r squared times so your r is 0.5 here squared. So that when you multiply that out, you'll get an answer. And then you take the middle diameter and you'll get 0.33 for the radius. So that will be 0.35 divided by 6 times 4 times pi times 0.33 squared. So that's the middle area, guys. It's good to have different colors of these things so that you can annotate and show a reference to your drawing, and that people can understand when they look at your working schedule. Okay, guys. So when you multiply that out, you'll get a total answer of 0.13 cubes. Okay, guys. And then if you add the two shapes, you will get 0.21 plus 0.13 is equal to 0.34 cubes. That's the totality of the cubes of this shape, of this column with the head, guys. Now I'm going to do a separate one, a separate video for when you are calculating the concrete, guys. So this one is going to go on, then it's going to be this is going to be video 1, and then the other one is going to be video 2. Okay, guys.